All right, guys. Today we are continuing our review over atomic theory. You had a Kahoot yesterday that will be for a grade. It will close today. It will not be available after today, so make sure that you go in and you take a look at that. Most of the questions were in regards to the concepts or ideas. If we go back and we look at our tracker for this unit, and reviewing what it is that you need to know for atomic theory. You need to be able to describe the various theories. What did the scientists discover? What was the name of their experiment? And what was the significance behind what they did? We also did describing the mathematical relationships between energy, frequency, and wavelength, which I'm going to work a problem with you here in a moment. We also calculated average atomic mass for isotopes. We'll review that. And then tomorrow we'll look at electron configurations a little bit closer and get into those quantum numbers. We also talked about the difference between scientific theories and hypotheses. So make sure that you do that Kahoot just to kind of revisit some of those questions and what you'll be seeing on the exam. Today, as I said, we're focusing on the calculation portion of this unit. And we had, starting with electromagnetic spectrum, we had discussed the various waves. Remember, electromagnetic radiation are waves of energy, frequency, and wavelength that that have this ability to manipulate electrons, is what Bohr began to discuss in his while he was trying to describe where an electron is. And so for this portion, remember that between wavelength and frequency, there is an indirect or inverse relationship, meaning if wavelength is getting longer, then frequency is going down. Also, energy is going down as well. So an inverse or indirect relationship is when one goes up, the other goes down. And we see this between wavelength and frequency, and also wavelength and energy. The direct relationship that we see here is between frequency and energy. And that means if it's direct, if frequency is increasing, then the energy of that wave is also increasing. And so we can calculate those relationships. And so I'm gonna do a practice problem or two with you to refresh your memory. And so we can there were three formulas that come up when calculating wavelength, frequency, and energy. And the first one is looking at specifically the relationship between frequency and wavelength. If we take the frequency of a wave and multiply it times the wavelength, we find that we get the speed of light. And the speed of light is a constant that is equal to 3.0 times 10 to the 8th meters per second. All right. The next calculation or formula that we see in this with electromagnetic radiation is calculating energy. And energy is equal to Planck's constant times frequency, where E is energy. Planck's constant is 6.626 times 10 to the negative 34, and that's joules per second. And then F is frequency, and we measure frequency in hertz. So I should put that. All right. The last formula we have is if we, for this energy problem, we have to have frequency. But sometimes you might be given wavelength instead. And in that situation, the formula is energy equals Planck's constant times the speed of light divided by wavelength. So same thing, E is energy, H is Planck's, C is the speed of light, and lambda is wavelength. Now, I think one of the biggest challenges was that some students were getting confused over what formula do you use? How do you know which one to use? Well, that all depends on what is the problem giving you and what is it asking you to find. That will determine which one you need to use. And so we can look at a problem here. It says, number 6, a helium laser emits light with a wavelength of 6.33 nanometers. What is the frequency of light? The first thing you should always be doing anytime you have a word problem like this is identify what do you have and what is it asking for. And in this case, we see that it's giving us wavelength and it's asking for frequency. This is our question, and this is our given. So we know that lambda is equal to 633 nanometers, and we need to find frequency. This is our X. So looking at our formula, what we're looking for is a formula that uses both wavelength and frequency in the problem. And so we can see this one has Planck's constant, energy, and frequency. We don't have wavelength. This one has wavelength. However, this equation does not have frequency. And we're not solving for energy. So here in this problem, we know what C is, and it both utilizes frequency and wavelength. So we're going to use the first equation, and we're just going to fill in what we have based on our formula. We know that C is equal to 3.0 times 10 to the 8th. We know that wavelength is equal to 633 nanometers. And we know that frequency is what we're trying to solve. So in taking our numbers and plugging it into our formula, we have 3.0 times 10 to the 8th is equal to frequency, which is X, times wavelength, 633. And we need to get X by itself. This needs to be isolated. Before we move forward, let's take a look at our calculator. Remember, when we're calculating wavelength, frequency, or any of this with electromagnetic radiation, we want to be in scientific mode. So to go to scientific mode, you do second DRG, and we're going to scroll over to psi and press enter. All right, now getting back to our problem, we need to get X by itself. And so here, if we had X and multiplied it times 633, we get 3.0 times 10 to the 8th. In order to get X, we need to do opposite of multiplying. So we need to get rid of this 633 and move it over to the other side. And we need to do opposite of multiplication, which would be division. So we're going to divide by 633 so that these guys cancel. But whatever you do to one side, you have to do to the other. So we're going to divide the other side also by 633. And then you're just plugging into your calculator after that. We put in the top number first, so 3.0. Remember, we don't put the times 10. We do second, and then we hit the double E right above 7. And all we need to do is put in the 8. So it should look like that. And then hit divide, and then 633. And we hit enter. Now, remember, we are rounding to the nearest hundredth, which is 2 places after the decimal. And you also need to be looking at this end over here to see if there are any times 10 of your numbers in scientific. It might not be, but in this case it is. We see the times 10 and to the 5th. We have to include that in our answer. If we don't include it, it's a big difference. So our answer here when solving for frequency is 4.74 because the 9 is going to move that 3 up 1. And then we're going to put times 10 to the 5th. And we're calculating for frequency, so our unit is hertz. All right, let's do one more like this. And we'll do 13 here. It says, what is the energy of light whose wavelength is 4.06 times 10 to the negative 11? What is the energy of light whose wavelength is 4.06 times 10 to the negative 11? All right, so in this problem, it's giving us wavelength, and it's asking, what is the energy? Their question. So we're going to go back, take a look at what our options are here. Let me write it down. We don't know what energy is. That's our X. That's what we're solving for. And it's giving us wavelength. 4.06 times 10 to the negative 11 meters. Sorry, having technical issues. Okay, looking at our formulas, we're trying to find the formula that has energy and wavelength. And so here, these two have energy in them. This one uses frequency. This one is using wavelength. And so this is the one that we're going to want to use. Let's see. Okay, so energy equals Planck's constant times the speed of light divided by wavelength. We're going to plug in our numbers here. We know that E is X. H is Planck's constant. This is a number you don't need to memorize. It will be given to you. 6.626 times 10 to the negative 34 times, I'm running out of space here, the speed of light, 3.0 times 10 to the 8th, whoops, sorry, divided by wavelength, 4.06 times 10 to the negative 11. Starting with the top, we're going to put our top numbers in the calculator here. So we're going to do 6.626 second E negative 34. Remember, when you're doing negative, you need to use the button down here. If you use a subtraction, it'll give you a syntax error. All right, times 3.0 second E8. I'm going to hit enter. That's not my answer. We still have to divide that by the bottom number. So divide 4.06 second E negative 11. Right. And there we go. There we have our answer. All right. Again, we are rounding. So that 6 is going to push at 9, which is going to push at 8. So we'd end up with energy is equal to 4.9 times 10 to the negative 15, and the energy is measured in joules. All right. Those are our wavelength frequency problems there. And so the other calculation that we did was looking at average atomic mass. There is a video already out there that I linked with the assignment in my YouTube channel. It's just some videos to show you how to do some work. Nothing exciting. Remember, when we are doing average atomic mass, that we have isotopes, and isotopes, they have the same number of the same protons, but their neutrons are different, so their masses are different. And so how do we calculate for the various masses? There were two things you had, well, one thing you had to do with one of the numbers, and that was to fix the percent. And like Beyonce, we go to the left. And so make sure that you are only changing your percentages. You're not changing your masses. You're going to take your new number, that was your percent, and you're going to multiply it times the mass that it goes with. Here were the notes that we took on that. It's around page 18 or so. So we have to first change the percent to a real number by moving the decimal to the left 2 times every single time. Then you multiply the new number with the mass that goes with it, with that isotope. Once you do that for every isotope, you simply are adding. So, and so make sure that you change your percentages, multiply it times the mass it goes with, and then add up all your totals. Again, there's a YouTube video already made, and you can watch it, fast forward it, because some of the stuff in there is not, I'm not talking about that. I had recorded it several years ago. But you can fast forward and watch how to solve several of those. All right, guys, I hope this helps. Make sure that you are studying. There's an assignment in Schoology with a few problems just to get that practice in. And it will be taking for a grade. Tomorrow we'll be talking about periodicity and reviewing electron configuration and quantum numbers.